Part 3 is the final part in our study of inverse functions, and I just wanted to start off by asking a quick couple questions actually. Given two tables of x and y coordinates, and so we could see tables down here. Given two tables of x and y coordinates, how can we conclude that the values represent inverse functions? Well, if we know what we talked about in the last video is that when you have a function f of x and you have x and y coordinates, if you have 2, 1, 3, 4, 5, 6, if by chance that you see another table of values for another function, it's an inverse if the coordinates are reversed. So in other words, if 2, 1 is a point on f of x, then 1, 2 is a point on f inverse. And we would have 4, 3, and 6, 5. If you just see that the coordinates are reversed, then you would have, then those values would represent inverse functions. And so I didn't really write that down, but that's the idea there. Given two graphs, how can we conclude that they are inverses? Well, graphs of inverse functions would be reflected about what? Let's see if you can finish my sentence here. Graphs of inverse functions are symmetrical with respect to symmetrical, WRT, shorthand for with respect to the line y equals x. So there you go. And we defined one-to-one functions in the last video, so we get a little bit of that here as well, the horizontal line test. And then let's get on down to example 1. Given the tables, does each function have an inverse? Why or why not? Well, a function would have an inverse if for every x value there's exactly one y value. That's a function. But for each y value there's not more than one x value. So we could see that the y values don't repeat, the x values don't repeat, so therefore it's a function. The y values don't repeat, so therefore yes, because the y values don't repeat. And what does that actually mean? Well, if you have a repeating y value, if you have two different y values and the same x value, then it's not one-to-one. Therefore, 1, 2, 1. Now, down here we see that in this next example, we can see that we have two y values of 6. It's the same y value, but different x values, so it's not one-to-one. So we say no, it's not one-to-one. 1, 2, 1. 1-to-1 would mean 1 y, 1 x, 1 x, 1 y. 1 y, 1 x, 1 x, 1 y, and we don't see that in example B. So for example 2, consider the 7 graphs of parent functions that we've learned this year. Which functions have an inverse and which functions don't? I can tell you right now that this is a very, very important question because it's a great review of what you've learned all year long. And let's just go through and think about, we should be able to do this by heart actually, thinking about the very first function that you learned, the graph of that looks like that. That's a constant. And then we learned linear functions. Then did we learn quadratic? No, I think we learned absolute value next, and then quadratic, and then cubic. How many is that? 1, 2, 3, 4, 5. And then we learned rational functions. Remember we had the vertical and horizontal asymptotes, so that's the rational. And then 1, 2, 3, 4, 5, 6. That's 7. What's the next? Oh, the square root function. So we had the square root function that looks like that. So there's 7. And so I'm just going to go ahead and circle the ones that have an inverse, the ones that are one-to-one. But I encourage you to pause the video and try that first. Okay, that's one-to-one. That's not. That's not. That is one-to-one. This is one-to-one. And that is one-to-one. So we have the, I guess we can list them here. The linear, it's a great review of your cosmic catalog. Cubic, rational, and square root. Functions have an inverse because they are 1, 2, 1. That's that simple, guys. So keep in mind your parent functions and what they look like and which ones are one-to-one. The blank functions do not have an inverse. Well, the other ones. The constant, it'll be good to list these though. The constant, the absolute value, and the quadratic, quadratic, oh my goodness, quadratic. Forget I did that. Quadratic functions do not have an inverse because they are not one-to-one. They are not 1 to 1. That's it.